Welcome friends to the Formula Engineering classroom. And in last lecture we discussed about the measurement of negative gauge pressure, that is vacuum pressure. In this lecture we will understand the concept of YouTube differential manometers. So what is the use of YouTube differential manometer? So as the name suggests, that is YouTube differential means this type of manometers are used simply to measure the pressure difference between the two gauge points. Means the YouTube meter is same, but in this type of manometers both the limbs are attached to two different containers. In the previous one only one limb was attached to the some container or pipe, but in this case both the limbs are attached to some container or pipe, and we want to calculate what is the pressure difference between that two gauge points. That is, that this tube is connected here some container, and this limb is connected to some tube or pipe or container this side here. So we want to calculate the pressure difference in this side. Okay, so let's start. So I'm attaching. Let first I'm saying that is initially when both the limbs are open to atmosphere. In that case, let the level of manometric fluid is here. There is some manometric fluid in the YouTube here. And let this is there is some manometric fluid. Obviously, the properties of this manometric fluid are completely known. That I'm saying this is specific weight is Wm. Okay. Now this side let connected to some pipe here. Okay. And this is the center line here, and there is some particular type of fluid in this one. Okay, there is some particular type of fluid in this one, and let we are saying this is gauge point A. This is gauge point A here, this center point, and let the specific weight of this fluid is, I am saying, W1. Okay, now this side, this right hand side of limb is also attached to some different pipe or container. Okay, so let this is gauge point B here, and in this one let there is some another fluid here. There is some another fluid here. Okay, and let specific weight of this one is W2. Okay, now so let if initially if I'm considering, or let we are saying that is pressure at the point A is greater than pressure at the point B. We don't know what is the difference between these two pressure at this gauge point A and B, but let's suppose we are considering that is pressure at the gauge point A is greater than the pressure at the gauge point B here. Okay, so obviously when this point gauge pressure is higher than this one, so in that case this type of fluid will try to exert a more force over here, and this will definitely, in this case, this manometric fluid level is going down here because A is greater than the B. So when the level of manometric fluid is down here, so in that case in the right limb the level of this manometric fluid is going up here. Okay, because we are considering that is PA is greater than PB, and we want to calculate what is the pressure difference between the point A and point B. We want to calculate this one. What is the pressure difference? So as we are saying PA is greater than PB, so let we are saying, so this is going down here, the level of manometric fluid going down. Okay, I think this is clear. And in the right limb, the level of manometric fluid going up this side. Okay, so now the level difference in the manometric fluid is this one, as the PA is higher and PB is lower. So obviously this is around here. So let's suppose I'm saying the difference in the level of manometric fluid is HM. Okay, and let I'm considering this one is h1, means h1 is the height of point A from this level. So initially let I'm marking this is level 1 and 2 initially when both the limbs are open to atmosphere. Now I'm marking this line that I'm saying this is 1 dash and 2 dash. Now, so I'm saying h1 is the distance from this level up to here of this point, and let h2 is the distance. Let I'm saying this is h2. h2 is the height of the B point from this level. Okay, so property of this fluid, that is fluid A, is known, that is W1. Property of this fluid, that is fluid B, is also known, that is W2. And property of manometric fluid is also known, that is Wm. Now we want to calculate what is this one. So I'm considering here that is at the level 1 dash 2 dash, and from the hydrostatic law we can say that that is at the same level the pressure intensity will also be same. Okay, so in that case we can simply write that is P1 dash will be equals to P2 dash. Okay, that is pressure at the point 1 dash, pressure intensity, and pressure intensity at the point P2 dash will be same here. So let first we will try to calculate what is P1 dash. So we can write P1 dash. So P1 dash is equals to, so let we are starting from this point at the point A. So at the point A the pressure intensity is PA. So first I'm writing this is PA. Okay. Now this pressure intensity is same at this level. Okay, this is same here. So PA is here, PA is here. Now we are moving down in this liquid. Okay, and I think from here to here the liquid is same, and this liquid height is equals to h1 plus hm. This is hm here. So height of this liquid from here to here is h1 plus hm, and specific weight of this fluid is w1. So as we are moving in depth the pressure intensity increases, so I will use the plus sign. So this is plus, w1 is the specific weight of this fluid, and height up to 1 dash point is h1 plus hm. Okay, so now we are here. So this is the pressure intensity at the point 1 dash. Now we will calculate the pressure intensity at the point 2 dash. So that I'm writing here P2 dash will be. So we will start from this point. So at this point B the pressure intensity is PB. So this is PB. Okay. Now this pressure intensity PB is throughout same here. Now when we are moving down here the pressure intensity increases because we are moving down here, and specific weight of this fluid is W2 and height of this fluid is H2. So pressure intensity increases, so we can write here this is fluid specific weight is W2 and height is H2. Okay, so now we are here. Now again when we are moving down here, and obviously this fluid is manometric fluid, so we know the property Wm is the manometric, that is the Wm is the specific weight of manometric fluid, and hm is the depth here up to the point 2 dash. So again we are moving down, pressure increases, so we can write and plus sign here, and we can say this is Wm hm. Okay, so now in this case now we have the value of P1 dash and P2 dash, that is the pressure at this level 1 dash 2 dash, and by the hydrostatic law we know that P1 dash will be equal to P2 dash. So we can equate them and we can write there is PA plus, that I'm opening the bracket here, W1 H1 plus W1 HM will be equals to, this is PB plus W2 H2 plus WM HM. Okay, now so we want to calculate PA minus PB. So we can rearrange the equation. We can write PA minus PB. I'm taking this is left hand side here, and right hand side I can write that is W2 H2 plus W1M HM minus this value here, so W1 H1 minus W1 HM. Okay, so this is the pressure difference between these two gauge point A and B. Okay, now let's suppose if I'm saying both the pipes or container having same fluid. So let I'm saying let W1 equals to W2, that is equals to, let I'm saying this is W of water, means both the pipe carrying water. Okay, and if H1 is equals to H2, and that I'm saying this is equals to H, means what? Means you can see here, this is line, from this line point A is H1 height above, point B is above the height H2. So if I'm saying H1 is equals to H2, so in that case we are simply saying that is the point A and B both are in a line. Okay, point A and B both are in a line, means the level of both the pipe is same. Okay, so in this case I'm saying that is both the pipe carrying the same fluid, that is water, and the level of both the pipe is same. So in this case I'm saying H1 is equals to H2, that is equals to H. So from this case, when I'm considering this one, so you can see here as W2 and W1 are same and S2 and H1 are same. So W1 W2 equals to WW and H1 S2 equals to H. So this term W2 S2 is cancelled out with W1 H1. Okay, so now we can write that is PA minus PB will be equals to WM HM minus W1 is now W of water into HM. This is a special case I'm considering here. Otherwise, the general case is this one normally. Now, so just a minute. So here, so W M H M W of W H M. So HM is common here, so we can take it common here. So I'm writing HM. I'm taking common here. So WM minus W of W, and let I'm writing this is delta P. Now, so in this case, let if I want to calculate this pressure difference in terms of head. Okay, in this case I want to calculate this pressure difference in terms of head or in terms of meter, or that in terms of meter of water or head of water. So we can simply calculate by by dividing this pressure difference of specific weight of water, that is rho g. So this will be in terms of head of water. So this much is the pressure difference will be equals to this much of head of water by dividing W of W. So this side it will be HM, then W of manometric fluid divided by W of water minus 1. Okay, so I think this term is the specific gravity of manometric fluid now. Okay, so we can write this one, that is HM is specific gravity of manometric fluid minus 1. So let here I'm writing this is delta P W of W is equals to HM specific gravity of manometric fluid minus 1. So why I'm driving this one, why I'm taking the special case here. So let's take a look here. In this case you can notice that is this is specific gravity minus 1. So if this specific gravity is greater than 1, then this term in the bracket will be positive. Okay, and obviously when we are considering that is W1 and W2 both are water, that is W of W, and let here this fluid as the this water, this is water and this is also water. So both this fluid, this that is water and water here are floating above this fluid. So obviously this fluid is heavier. So means the specific gravity of this fluid is greater than the specific gravity of this one, or specific weight of this manometric fluid is more than this flowing fluid, that is water. So means in this case this term will always be positive. Okay, what if this term is negative? Means if I'm saying this manometric fluid is lighter than this one, this flowing fluid, so obvious in this case when the specific weight of manometric fluid is less than the specific weight of the fluid that is flowing in the tube, so this fluid will move up inside this fluid because this is lighter and this is heavier, and this will goes down here, so we can't measure the pressure difference in that case when this is going to be negative in this situation. Okay, so this term will always be positive. So this position we are defining here, this position of this manometric fluid is defined as upright. This is upright. This upright condition means upright condition is that in that case the u tube is in this direction, in this position, that is u shape in this downward direction, and in that case this manometric fluid will always be heavier than the flowing fluid in the tube, so that the flowing fluid can easily float over this heavier fluid. So this we are defining, this is upright u tube differential manometer. What if this is lighter, and what will be the position of this u tube manometer, differential manometer, if I'm taking the lighter manometric fluid, that is if this manometric fluid is lighter than the flowing fluid in the tubes. So let's take a look. So I draw this figure, and in this case the position is just reverse as compared to the previous case, and this case wm, let if I'm saying this is wm dash is the manometric fluid, and here are the fluid in the pipes are w1 and w2. Okay, let this is w2 here, and obviously in this case when the manometric fluid is floating over the flowing fluid, so definitely this is lighter than this one, so we can say that there is specific weight of manometric fluid is less than w1 and w2. Okay, but in previous case when we discussed, in that case the w1 was greater than the w1 and w2. So this type of position is defined as inverted. This is inverted. Okay, this is inverted u-tube differential manometer. So in this case the manometric fluid specific weight is less than the flowing fluid. So to solve this type of problem that I'm saying, here is the 1, here is the 2, I'm marking the level here, and again we know that is that if I'm using this space here, again I'm saying that is P1 will be equals to P2, at the same level the pressure will be same here. So first I will write P1, and I'm starting from the point A, so at the point A the pressure is the gauge pressure, that I'm saying this is PA, and yes obviously in this case I'm also considering that is PA is greater than PB, and you can see here as the PA is greater than PB, this liquid is going to push this manometric fluid up here because the pressure is higher here in this side, and this liquid is going down here because the pressure at the B side is less. Okay, so at this point the pressure is PA. Now when we are writing P1, so at the same level the pressure will be same here. Now we are moving upside, so when we will move the upside, in that case the pressure intensity is going to be decreased here. Okay, so up to this height the liquid of specific weight W1, and this height from this level to this point 1, this is H1 plus HM. So I'm writing this is minus, sorry this is minus, I'm writing here minus W1 is the fluid specific weight and this is H1 plus HM. Okay, so now we are at this level. Now let's write the equation for the P2. So P2, we are starting from here, B point. So here the pressure is PB. And again, same level, same pressure intensity. Again, we are moving up here. So pressure intensity is going to be decreased. So for this height, that is H2. So we can write that is minus W2 H2. Okay. So now we are here at this level. Now here is the manometric fluid. Up to the height 2, the height of the manometric fluid is HM. Again, we are moving up. So pressure intensity is going to decrease. So we write minus WM HM. Okay. Now let's equate them. So we can write that is PA minus W1 H1. I'm opening this one, and W1 HM. Okay, and this will be equals to PB minus W2 H2 minus WM HM. Okay, so in this case, we want to calculate the pressure difference PA minus PB. Okay, so I'm taking PB this side, left hand side, and taking this term this side. So I can write this is W1 H1 positive plus W1 H1 also positive minus this term, that is W2 H2, and minus WM HM. So this is the generalized case in this case. Okay, so this is the generalized case. Now again, we are considering the same case as we considered in the previous one. Let same fluid is flowing in both the pipes. So W1 equals to W2. And I'm saying this is W of water, same fluid, and the level of the pipe is also same. So we can say there is H1 is equals to H2 is equals to H, as we discussed in the previous case. So applying this condition again, we can see here W1 equals to W2 and H1 is equals to H2. So these terms are going to be cancelled here. And that I'm writing this is delta P here. So delta P is equals to W1 HM minus WM HM. Okay, so let's taking HM common here. So I can write W1 is as W of water, as we discussed here, minus manometric fluid here. Okay, and now we want to calculate this pressure in terms of head. So we can write delta P by W of water. We are calculating in terms of meter of water. So here we can write this is HM and this will be W of water. This is going to be 1 here minus W of manometric fluid. This is actually WM dash. Okay, this is WM dash everywhere here. So WM dash upon W of water. So again, this is going to be specific gravity of manometric fluid. So we can write this is equals to HM 1 minus this is specific gravity of manometric fluid. So in the previous case, the equation was specific gravity of manometric fluid minus 1 when the condition was upright, position was upright. And now in this case, the equation is going to be 1 minus specific gravity of manometric fluid when the position is inverted. But take a look here. We are saying the flowing fluid is water. Okay, this is water. And this is the manometric fluid. And obviously this is lighter than water. Okay, so this is floating over here. So if this is the lighter than water, so in that case the specific gravity of this manometric fluid will be less than 1 here. And again this term is going to be positive as in the previous case. So I think this is clear. So we can conclude that so when the position is upright, in that case the specific weight of manometric fluid or gravity, specific gravity, that saying the specific weight here will be greater than should be greater than to the flowing fluids or container fluids. And in case of inverted U-tube manometer, the specific weight of manometric fluid will be less than this one. In both cases, this is going to be positive because we know as is PA is greater than PB, this delta P will also be positive. So that's why this is here it is positive. Height will always be positive. In this case, we also considered here that is PA is greater than PB. So again, this term is also positive. That's why this is greater than the 1. So this is also positive. I think the terms are clear. So guys, if you like the lectures, please subscribe the channel, comment your doubts, like and share the knowledge as much as you can. Thanks for watching. See you in the next lecture.